Welcome to Fluid Mechanics lectures by Civil Thinking, and today we are going to solve a problem on parallel pipes. Now for better understanding, I suggest you to please watch the video lectures in sequence as in the playlist. You can find the playlist link in the description or also you can click here. Now coming to the problem, the difference in elevation between a watershed and a reservoir is 150 meters and the distance between them is 48 kilometers. Now what is it saying? Let us say this is watershed, for example. Let us say this is a reservoir, okay? Now let us keep them open to the atmosphere like this. Now the difference in elevation between the watershed and the reservoir is 150 meters, okay? Now let us say the water level in this is up to this level, okay? Suppose this is a watershed. Let us say this is reservoir. Now let's say the water level in reservoir is up to this level. This is the water level in the watershed, right? This is the water level in the reservoir, okay? Now according to the problem, the elevation difference between them is 150 meters. So let us say the elevation between them, it is 150 meters, okay? 150 meters. Let us say this is the surface of watershed and it is marked as 1 and this is 2, okay? So, and the distance between them is 48 kilometers. The watershed and reservoir were originally connected by a single pipe. Okay. Now let us say there is a pipe connecting these two. Okay, this is the single pipe which was initially connecting the watershed and the reservoir, right? And the distance between them is 48 kilometers. So let us say the distance between them is 48 kilometers. Okay, this is the distance between them. The watershed and reservoir were originally connected. Okay, now it was to designed to carry 22.5 million liters per day. Okay, now the discharge in it is 22.5 million liters per day. Okay, so let me convert it million liters per day to SI units. So it is Q1 was 22.5 million. Million is 10 to the power 6, right? Now liters per day. Okay, now it is 22.5 multiplied by 10 to the power 6. Now 1 liter is 10 to the power minus 3 meter cube. So right, 10 to the power minus 3, it is going to be meter cube per day. Okay, now I will convert day into seconds so that it will be discharge will be in meter cube per second. So it is 22.5 multiplied by 10 to the power 6 multiplied by 10 to the power minus 3. Now meter cube per second. So we converted day into seconds, so I have to divide something. Now 1 day is 24 hours, so I write 24 hours. 1 hour is 1 hour is 60 minutes, so I write multiplied by 60. And 1 hour is 60 seconds, so I multiplied by 60 again, so that meter cube per day will be meter cube per second. So this is the q1. So let me simplify it. So I will get q1 in terms of meter cube per second to be, let me use a calculator. Okay, it is approximately 0.26 0.26 meter cube per second. Okay, this is the q1, 0.26 meter cube per second, right? Let me put the q1 here and erase everything. Now let me erase all of this. It was later found necessary to increase the flow to 31.5 million liters per day. Okay, now initially it was this were watershed and this was reservoir, and it was connected with the help of this pipe, right? Single pipe. Okay, so the discharge was initially this 0.26 meter cube per second. Now for some reason we needed to increase the flow rate. Okay, we needed to increase the discharge through this pipe to 31.5 million liters per day. Okay, so how they decided to do that? They decided to increase the flow by, it was decided to lay another pipe of same diameter alongside the first pipe. So in order to increase the flow rate between the watershed and the reservoir, they wanted to increase the watershed, they wanted to increase the flow rate, means they wanted the water flow to be fast between watershed and reservoir. So what they did, they decided to lay another pipeline parallel to this pipe. Okay, so that the discharge will increase. Evaluate the diameter of the pipes and length of the second pipe. Now we have to find the diameter. Let us say the diameter of this pipe is d. Okay, now it was decided to lay another pipe of same diameter, so we laid another pipe parallel to this. Okay, something like this was another pipe, I will draw it later. So the diameter was the same diameter, let its diameter be d of the first pipe, so the diameter of second pipe is also d. Now we have to evaluate the diameter of the pipes and the length of the second pipe. So initially we will diameter of the pipe. Okay, now let us see how we will do that. Now let us say energy per unit volume at 1 is E1, right? This is the energy per unit volume at level 1. Now let us say energy at this reservoir surface is E2, energy at point 2 is E2, right? Now let's find the value of E1 and E2. Okay, now energy at 1 will be equal to P1 divided by rho g plus V1 square divided by 2g plus Z1, right? So let us say this is open atmosphere. Okay, this surface is open atmosphere, so here the P1 will be equal to atmospheric pressure, right? So it is P atmospheric, P1, because it is open to atmosphere. So in terms of gauge pressures, we assume atmospheric pressure to be 0. Okay, so P1 is 0. Now you can see this is the water surface is resting. Okay, this is the water surface and we assume the velocity at this surface is 0. So V1 is 0. Now Z1 is the elevation of this one surface from some reference. Okay, so in short E1 is going to be Z1, right? Because it is going to be 0, this all of thing is going to be 0, so E1 is equal to Z1, right? Like this will be 0, all of this. Now this will be also 0, so I'm going to erase all of this. So we are left with E1 is equal to Z1. Okay, so let me write here E1 is equal to Z1. Okay, now let's find the energy per unit volume at level 2. Okay, energy at 2 will be equal to P2 divided by rho g plus V2 square divided by 2g plus Z2, right? Now again we are assuming this reservoir surface, it is open to atmosphere, and that means the P2 is atmospheric pressure, and so the gauge pressure here is 0, so P2 is 0, right? Again the velocity at this the reservoir surface we are assuming it is really very small, so we can neglect the velocity of this because velocity in this pipe is very high, right, as compared to the velocity of this surface. So we will neglect the velocity, so V2 is 0. This is also 0. So E2 is, this is 0 plus 0 plus Z2. So E2 is Z2, right? So we have another equation. E2 is equal to Z2, right? So let me erase all of this, right? Now we will apply total energy equation between 1 and 2, okay? Apply total energy equation, right? Total energy equation between 1 and 2. So the total energy equation, in fluid mechanics, we have an equation which we call as total energy equation, right? Now, according to the total energy equation, energy at 2 is going to be equal to energy at 1 minus head loss in this, right? Now in the problem, it is the minor losses are neglected, right? The losses due to the the entry of the pipe, or the exit losses, entry losses, okay, they are neglected, right? But we are provided with this: take F is equal to 0.008 for each pipe, which is the coefficient of friction. It means we have to consider only the losses due to the friction in this pipe, right? So energy at 2 will be equal to energy at 1 minus head loss due to friction, okay? This is the energy equation when we apply it between 1 and 2. Why it is like this? Because you see, energy at 2, we can let us first assume energy at 2 is equal to energy at 1, right? But when the water flows from this pipe, there will be losses, right? For example, let the energy was here was E1, right? When it goes down, the energy is losing, right? It is losing the energy, so the energy becomes E2. So E2 is E1 total energy minus the loss of energy from this point to this point, right? So this is the reason energy at 2 is equal to E1 minus head loss due to friction, right? Now what do we have to find? We have to find the diameter of the pipes, okay? We have to find this D. We have to find the diameter. So let us put the values. We get E2 is Z2, right? In before we got E2 is Z2, so it is Z2 here. Now E1 is Z1, so it is Z1 here, minus HF, right? So when I rearrange it, so what I will get, let me write it like this: Z2 minus Z1 is equal to minus HF, or HF is Z1 minus Z2, right? So head loss due to friction is Z1 minus Z2, but remember we had to find the diameter. We know the equation of head loss. We know the equation of head loss. Let me write. We know head loss due to friction is FLV square divided by 2GT, right? But we also know we have reduced this to in the discharge form like this. Head loss due to friction is FLQ square divided by 12.1 d5, okay? It is the same. When you just change the velocity to q, it is going to be like this. This is really a simplified formula, okay? And it is really important. Now which one we are going to use? You see, we are provided with discharge, we are provided with the q, right? We are not provided with v, so we are going to use this formula, okay? So here we will write FL q square divided by 12.1 d power 5, where d is the diameter, right? And we have to find this d, right? We have to find the diameter. We have to find this d is z1 minus z2. Now what is z1 minus z2? Okay, now z1 is the elevation of 1 from some level. For example, let the surface be here, okay? Let me erase all of this first. Now Z1 is from here up to here, right? This is Z1, right? Now Z2 is from here to here. This is Z2. Now, can you tell me what is the value of Z1 minus Z2? Now this is Z2, right? Up to this point. So when I connect it like this, so this was Z1 and this is Z2 is from here to here, right? Because Z2 is here, so it is Z2. So Z1 minus Z2 is this part, right? From here up to here, this is Z1 minus Z2, right? So from here to here it is Z1 minus Z2, which is 150 meters, right? Because from here up to this point, it is here from here to here, right? Which is 150 meters. So we're going to write Z1 minus Z2 to be 150 meters. Now F is given 0 0.008, 0 0.008, right? Now L and Q square. Let me erase this. L. L is 48 kilometers, right? The distance between them or the length of the pipe, 48 kilometers, 48. Now kilo is 10 to the power 3, it is meters. Now F, L, Q square, Q is this, 0.26, FLQ square, right? It was square, divided by 12.1, D5, multiplied by D power 5 is Z1 minus Z2, which was what? 150, right? Now, when you simplify this equation, okay, using the calculator, you will get the value of t. You have to put all of these things in the calculator. If you don't know how to solve this equation to find d directly, without too many steps or just in one step, please comment. I will tell you how to do this. So let me use the calculator. Okay, I get diameter to be 0.427 meters. Okay, I hope I didn't do any mistake in the calculation. Now this is what I get in the diameter. If you get a different value, please let me know in the comments. Now we found the diameter to be approximately 0.427 meters. Okay, so we've solved the first part of this problem. This is the diameter. Now what is the second part of the problem? And the length of the second pipe. Okay, we have to find the length of the second pipe. Now let me tell you what we have done here. Let me erase all of this. Now another pipe was laid right along the same diameter alongside of the first pipe. So we will draw another pipeline here. Now we have to find the length of this pipe, right? Now we don't know the length of the second pipe, how much pipe we need. Now you may say the question that the distance between them is 48 kilometers. 48 kilometers is the distance between them. So the length of pipe 2, the second pipe, this is pipe 2, is 48 kilometers too. But no, it's not like this. We have to design the length of this pipe so that the discharge is, where is it? It was later forecasted to increase the flow to 31.5 million liters per day. We had to choose the length of this pipe so that the discharge is 31.5 million liters per day. So let it be Q. It is 31.5 million. Million is 10 to the power 6 liters per day, right? It is, now liter is 10 to the power minus 3 meter cube. Now per day, I will convert it into per seconds. For that, I have to multiply it with 24 into 60 into 60, right? Now the length of the second pipe has to be something so that the discharge is this. Okay, so let me simplify this first. What will be the value of discharge? Okay, it is 0.3646 meter cube per second. Okay, now let us say the length of the second pipe is L. Okay, now we need this discharge. Okay, so again let's apply energy equation between 1 and 2. Now let us say we know initially we know energy at 1 is Z1, as we know from before. Energy at 2 is Z2, right? Now according to the total energy equation, energy at 2 is equal to energy at 1 minus head loss due to friction, right? Now E2 is Z2, so Z2 is equal to E1 is Z1 minus head loss due to friction, right? Now we have to find the length. Okay, now head loss due to friction is FL Q square divided by 12.1 D5, right? So what we get now, it is Z2 is equal to Z1. Now let us say Z2 minus Z1. I will put the Z1 in this direction. It is equal to minus HF, right? So it is minus HF. So HF is Z1 minus Z2. Now HF is this FLQ square divided by 12.1 D5. Now Z1 minus Z2 is 150, as we found before, 150 meters. Now F is what? 0.008, right? So let me write it here. Now F is 0.008, right? As it's here. L is the length which we have to find, multiplied by Q. Q has to be this, right? 0.3646, 0.3646 square, right? Is square divided by 12.1 D5. D is the diameter. Now we found the diameter of the first pipe, and it was said diameter of the second pipe is same, right? Same diameter. So diameter of the second pipe is also 0.427, right? So I will write 0.427 power 5 is equal to 150 meters. Okay, now when you simplify this, you'll find the value of L. So let me use a calculator to simplify. Okay, I get length to be 24306 point 55 meters. Okay, now if we convert it into kilometers, how it is going to be? It is going to be 24.30655 kilometers, right? Which is approximately equal to 25 point 31 kilometers. Okay, so we need the length of second pipe to be 25.31 kilometers, but the length of the first pipe was what? 48. So but here we need only 24, so we just need half of this. Okay, approximately, because 24 is approximately half of 48, right? So we don't have to lay all of this length of the pipe. This way we will be economic, we will save the money, we don't have to lay all the length. So what we need to do here is we need to lay only 24 kilometers. Okay, so we can just begin from the beginning, from this point or this point. So let us say the line will be here. We just need only this length of the second pipe. Okay, this is the second pipe. We don't have to from connect from here to here. We will save the money of this much of pipe, right? Because we don't need this much of pipe. So in this way we solve this problem. I hope you understand the concept. What I wanted was make you understand the concept. So this is how we solve it problem, and if you have any doubts, please comment, and see you in the next class. Thank you. Hello.